Hi friends, in this episode we will see about the mechanical type steam trap operation. How mechanical type steam trap works. Mechanical type steam traps operate on the difference in density between steam, a vapor, and condensate, a liquid. They are actuated by a float or by an inverted bucket, responding to changes in condensate level. Steam is always lighter and hence has a density much lower than condensate. A mechanical type steam trap will allow only the heavy condensate to get discharged and hold back the steam. This is the schematic diagram of float type steam trap. This is the inlet line, this is the air cock float, and this is the outlet line. Liquid condensate will go out this cup. This is a special type steam lock release. It is available for mechanical type steam trap only. Float will be always above the water level or condensate level. Ball float trap. These float traps or ball float traps are ideal for process heating applications. Float traps are designed in such a way that the wall seat is always submerged under the water, preventing any steam loss. The discharge is continuous and modulates with the condensing rate. It is unaffected by changes in inlet pressure. A separate thermostatic air vent is independently purges air giving a fast startup. This is the thermostatic air vent. Air entering the trap immediately discharged through a high capacity auxiliary air vent. The condensate enters the trap body, a ball float being for hollow is a hollow, so it will float easily. Floats over the condensate. As condensate level increases, condensate causes the ball float to rise. When the level increases, ball float will increase above the condensate level. And place the modulating discharge valve in a position that will pass the condensate continuously as it enters the trap. The condensate level in the trap body is maintained above the discharge valve to provide seal against the loss of steam. So when the level reaches the outlet line, that is float will above the line, then only it will allow the condensate to go out. So until that, the condensate will collect up to that outlet line. So it will act as a seal. Now we can see the advantages and disadvantages of the ball float trap. Condensate discharge temperature closely follows the saturation curve. It discharges condensate continuously as rapidly as it forms. Whenever condensate forms, it continuously discharges the condensate. High air venting capacity through auxiliary balanced pressure air vent, which is self-adjusting for varying steam pressure, not affected by high back pressure. High thermal efficiency at both light and heavy loads. Continuous modulating discharge does not create pressure disturbances, which may affect control in air heating coils, shell and tube exchanges. Responds very quickly to condensate load changes. Steam lock release facility is available. Inlet and outlet line facility easily installed at very low cost. Also available with vertical inlet and outlet connection. Wide range of RPs are to suit inlet pressure. Thirdly, it is very large and heavy. Float easily damaged by water hammering. Can only be mounted horizontally, suitable only for relatively low pressure. Requires auxiliary air vent, which is an additional source of failure. Primary failure mode is closed, so you cannot check whether the function of trap is correct or not, as it is failure mode is closed. No self draining. Cannot be used on high degree of superheat. Applications subjected to freezing must be protected with insulation or steam lock release. Now we can see the inverted type steam trap working principle. This is the inverted type steam trap schematic diagram. Inlet line, this is outlet line, the bleed hole, condensate will collect air. This is the inverted bucket. How inverted bucket type trap works? This mechanical type uses an open inverted bucket as a float. The trapping principle uses the difference in density between steam and water. The construction of the trap is such that the trap inlet leads into the bottom and opens end of the inverted bucket. Discharges through an outlet valve above the inverted bucket. As the inverted bucket sinks and floats within the trap, it opens and closes the valve. This is the inverted type bucket in that line. Condensate will steam will collect and it will condense here. The level raises. Float this bucket will float above this level and it will open the outlet valve and condensate goes out. The construction of the trap is such that the trap inlet leads in the bottom and open end of the inverted bucket. Discharge is through an outlet valve above the inverted bucket, the discharge line. As the inverted bucket sinks and floats within the trap, it opens and closes the valve. Inverted bucket traps work by opening and closing a valve connected to a cylinder. Here is a cylinder, valve is connected. That resembles an upside down bucket. A steam collects in the bucket, it causes the bucket to float higher and higher, and the condensate collecting below it. Condensate will collect here inside the bucket, below the bucket. And the bucket rises high enough, it opens the valve and condensate drains away. When the level rises high above, this will slide open and the valve get open and the condensate will go out. This is the working principle of inverter type steam trap. Now we can see the advantage and disadvantages of inverted bucket type steam trap. Advantages are it is simple in construction, rugged, so it is resistant to water hammer. Condensate discharge temperature closely follows the saturation curve. It is reliable. Its function is not impaired by high back pressure. Fast response to changing condensate load. So it will work on different condensate load. Marginal air handling during startup due to poor air venting capability is one of the main disadvantages. So it will delay the trap lining up condition at the beginning. It's not self-draining, subject to required insulation. Can lose priming and it's not self-priming. Can be mounted only in a single position. Failure mode is unpredictable, open or closed, but usually it is selected as open. So it will help when the tap get damaged. Low loads or high superheat condition can lead to loss of water seal. In such condition, trap will vent live steam. So when you see live steam, then also you can take it for repair. It will intermittent discharge of condensate only will be available for inverter type bucket steam trap. Now we can see the criteria required to select a steam trap. Trap selection criteria. The characteristics of steam using equipment is required. Type of equipment: steam pressure, high pressure or medium pressure or low pressure. Condensate load. How the condensate load will be. Then the condensate temperature, venting requirements, drainage requirements, ambient temperature, maintenance requirements. Type of equipment, whether it is coil or vessel or heat exchanger or turbine. Steam pressure, high pressure or super steam pressure or medium pressure or low pressure for reboiler used. Condensate load depend on the how condensate is produced. Condensate temperature also required. Venting requirement, drainage requirement, ambient temperature required, whether the trap will get freezing up, affected by the freezing up, and the maintenance requirements. Advantages of mechanical steam traps. Mechanical traps are able to operate in precise response to the flow of condensate without their performance being compromised by most external factors. This is one of their distinct advantages over thermostatic and thermodynamic steam traps, whose performance can be affected by external factors such as rain, wind, or even insulation. Steam used for secondary heating like coils, steam coils, vessel, heat exchangers generates a lot of condensate post heat transfer. So that will generate more condensate that can be easily collected through ball type or inverted bucket type. This large quantity condensate can handle by ball type or inverted type trap can be reused as a boiler feed water after getting treated in condensate polish unit. This is one of the main usage of bucket type and ball type flow type mechanical traps used to collect more condensate which can be reused in boilers. The version which have a steam lock release valve or only type of trap entirely suitable for use where steam locking can occur. The steam lock release system is provided in this ball type trap which is used when there is a lock in steam. It will drill open and release the valve, release steam. Failure mode is normally open in inverted bucket type, so it's safer on the application that requires this feature. For example, turbine drain, normally it is open, then you can take it for repair. Also avoids water hammering and consequent line damage which occurs in failure mode closed condition of the trap. Hope you might understand the mechanical type of steam trap, float type and ball float type and inverted bucket type operation, advantage and disadvantages, and the main advantages over the thermostatic and thermodynamic traps. And condensate collection is more and condensate load is more. Mechanical trap is advisable and suitable to select. Hope you might understand. Do not forget to subscribe and share with your colleagues and friends. Do not forget to put likes and comments in the comment box. See you in the next episode. Thank you very much.